So the next type of chemical reaction problem I'm going to be doing is decomposition. And decomposition is when you have one reactant compound and then it splits into the elements that make up that compound. But this one that I'm doing, okay, no, that's the next one. So this next one is pretty easy, and it's one of the normal ones that you'll see. So it's 3. This is one of the ones that's already written out. AlCl3 yields Al plus Cl2. So chlorine is a diatomic, so the subscript has to be 2. And now we have to balance it all out. So we want to get the same amount of aluminums and the same amount of chlorine. So what we can do is we can put a 2 here to make 6 chlorines. And then we can put a 3 here to make 6 on this side. And then since we have 2 aluminums on the reactant side, we can put 2 here. And it's all balanced now. And that's it for that type of decomposition problem. It's really easy. Just don't overthink it. You have your 2 elements that make up the compound, and it just splits into those 2 elements. But make sure you are being considerate of the diatomic molecules and that they have to have a subscript of 2, and those are break off. So you know the acronym. So this next one, I'm going to be doing number 20, and this one's a little bit different decomposition problem. It's one that actually a lot of people have questions on. So I'm going to make some notes about it. So it is calcium carbonate, CaCO3. And then when you have that triangle over the arrow, it means decomposition. It means heat is being put in for these for this compound to break up. So there is an exception for this one. I'm gonna make a little note of it after I finish doing it. So this actually breaks down into calcium oxide, and that's solid plus carbon dioxide gas. And carbonates actually have a little bit of a different rule. So the thing about this is that metallic carbonates, which we have in this case, break down into a metal oxide, which is our calcium oxide, metal oxide plus carbon dioxide. And a lot of people were asking me why it does not split up into Ca plus the carbonate. And it's because of this rule right here. This carbonate, when you have this carbonate, it has to form a metal oxide and carbon dioxide. So that is just something to note in the future. So in a way, the oxygen is just staying bonded to the metal, and then you have to take into consideration the charges. So this is +2, -2, so those cancel out. And then you have plus carbon dioxide. And that's it for decomposition. And I'm gonna do one combustion problem, and that's gonna be it for the videos, unless you have other questions and I can do more. So that's synthesis. Okay, now, combustion for this one. So this one is 25. Combustion. Okay, so 25 is acetic acid undergoes complete combustion. So acetic acid is HC2H3O2. See how it's acetic acid? It has acetate, which is C2H3O2. And then plus O2 yields carbon dioxide and water. And these are both gases. So when there is combustion, the water is gas as well. So you know it's combustion because you have to add O2. So when you see plus O2 and it's asking you what kind of chemical reaction it is, it's combustion. And when you have, your carbons and hydrogens and oxygens, that means it's going to yield your carbon dioxide plus water. So now what we have to do for this one is balance. And we need to have, so we have 3 oxygens on this side. And this is one of the ones that it gets a little bit tricky for people because there's oxygen here, and oxygen here, and then oxygen here, and oxygen here. So there's like basically double that type of element on both sides. So what I can do is put a 2 right here where I can get 4. So we have 4 plus 6. So oh, whoops, I'm getting ahead of myself. 4 plus 2 equals 6. So we have 6 oxygens on this side. And we can do 2 here and 2 here to where we can have 4 oxygens on this side plus another 2. So there's 6 oxygens on the products and reactants side. And then we have hydrogen plus 3 hydrogens. So we have 4 hydrogens on this side and then 4 hydrogens here. And then we have our 2 carbons and 2 carbons. So that's it for the combustion problem. And I can just barely talk at this point because I have been doing all these videos. So just message me if you have any more questions and I can work some more out. That's it.